Hello and welcome to this episode of Mrs. Mulvey's Math Movies. In this episode we're going to talk about orthogonal vectors. By the end of this short video you should be able to define orthogonal and use dot products to determine if two vectors are orthogonal. So I have a picture of this interesting building here. The reason I have this picture is because there are some orthogonal shapes in this particular building setup. Orthogonal is just a fancy word for perpendicular. And so if you look back here, notice I've got this building, this section of the building, and this section of the building, and I see the right angle in there, and so they are orthogonal. So again, orthogonal, fancy word for perpendicular, or forming right angles. And here are just a few more examples of orthogonal vectors. So now that you know that orthogonal is just a fancy word for perpendicular, let's talk about how you can determine if two vectors are orthogonal. The key idea that you need to remember is this. If two vectors are orthogonal, their dot product is 0. So really all you need to do in order to determine if two vectors form right angles is calculate their dot product. And so let's take a look at my example up here. I've got vector A, which has the coordinate, it's in component form, of 9, 3. Now remember, this is not the vector. The segment that connects that point to the origin, that's the vector. Here's the vector 2, negative 6. There you go. Now you can actually see the vector. And again, the point is not the vector. The segment connecting the point to the origin, that's the vector. So they look to me like they're orthogonal, forming right angles, but let's calculate their dot product. And when we have the vectors in component form, to calculate the dot product, and remember, this means the dot product of A and B. What we're going to do is we're going to use the formula that says multiply the x values, so ax and bx, multiply the y values, ay and by, and add them up. And so when I multiply the x values from each point, I have 9 times 2. When I multiply the y values from each point, I have 3 times negative 6. When I multiply them, this gets me 18, this gets me negative 18, and when I add them, I get 0. So yes, the vectors look like they're perpendicular. And in this case, we're using the word orthogonal. Their dot product is 0, so that means they are definitely orthogonal. So that's it. The test is, if the vectors are orthogonal, their dot product is 0. That's all you need to do. So go ahead and give each of these a try. In practice 1, you're going to check for orthogonality with the vector 4, 4 and negative 2, 3. And in the second practice, you're going to check the vectors 6, negative 3 and negative 4, negative 8 to see if they're orthogonal. So go ahead and try those out, pause the recording, and when you come back, we can check your answers. Okay, so what you should have gotten is that this one is not orthogonal, and this one is. This one does not have a dot product of 0. This one does. So if you got that, you're good to go. You can shut down the recording. If you didn't get that, let's take a look and see what happens with these dot products. So again, to find the dot product, you take the x values and multiply them. In this case, that's 4 times negative 2. Then you take the y values and multiply them. That's 4 times positive 3. And add them up. That gets me negative 8 plus 12. That's 4. The dot product is not 0. So these vectors are not orthogonal. Let's take a look at the second one. In the case of the second one, I multiplied the x values. That's 6 and negative 4. I multiply the y values, negative 3 and negative 8. Add them up. So when I multiply the 6 times the negative 4, it gets me negative 24. Negative 3 times negative 8 is positive 24. Add them up, I get a value of 0. If the dot product is 0, the vectors are orthogonal, so yes, these vectors are orthogonal. And so that's it. Please let me know if you have questions. Bye-bye.